We might get started. So my name is Andy Botting. This is my colleague Jake Yip. We work for the University of Melbourne on the Nectar Research Cloud. We're part of the core services team, which manage the kind of top level OpenStack services. And then we work closely with site teams who manage the hardware which powers our cloud. So in our talk today, we're going to talk a little bit about the architecture of our cloud, and then we're going to go into details about the kind of services that we monitor, some details about how we specifically monitor the sites and how they're operating, and lastly we're going to go into some of the tools that we use and some of the techniques. So this is a very simple diagram of our architecture. We're a federation, so we as core services are the kind of central body that ties the federation together, and we've got 8 sites across Australia and New Zealand. We're running a Cells v1 architecture, and you've got some numbers there, 11,000 users, 37,500 cores, and 234 petabytes of RAM. That was the figure that I got on Friday. And so, yeah, as I mentioned, being a federation means that we have there's a separation between the core and the sites, and that does create some challenges in how we operate. So here's a diagram of our control plane. I'm sure this will look fairly typical to a lot of you who operate clouds as well. We don't use containers or anything. We're a little bit old school. We're using some large compute nodes with an undercloud, and we run our services within that. We split them up into 2 tiers. The tier 1 services are the really critical services. So you've got Keystone, Nova, Glance, Neutron, Cinder, Swift. And then we have the tier 2 services, which are the ones that are used less and tend to be the ones that depend on the tier 1 services. The tier 1 services tend to have more requirements for hardware, so they're on beefier boxes, more cores, more RAM, that sort of thing. Tier 2 services don't get as much use, so they don't need quite as much resources. You can see there in the diagram we've got the 2 tracks there, the tier 1 and tier 2 service APIs. Down the bottom we've got the workers there. Got the message queue and database in the middle. You can see we've got the little laptop diagram there, indicating the users. They generally connect through the dashboard, or they can connect straight to the load balancer if they're making CLI calls. So going on with our overview, we're going to talk a little bit about some of the services that we monitor and how we do that, including load balancer and the control plane. So what we're really trying to do here is we're trying to test all the layers, starting right at the top where we've got the load balancer endpoints that the users will connect to, and we're going to work through all those layers so that we can quickly identify when we have an issue at what layer that issue is. So first of all, we're testing load balancer endpoints, so we're testing your Keystone, Nova, those sort of services, and then testing the dashboard, obviously. With the APIs, we're testing not only the load balancer endpoint, we also want to test all the members of the pool for that service as well. We want to test that the services themselves are working correctly, so not just that the port is open and it's accepting connections. We also want to exercise that service a little bit as well to make sure that it's actually working correctly. And then we want to test that resources, the existing resources, are already working. So it's one thing if your API service goes down, users can't create new resources. What about those virtual machines or networks or other resources that users might have? You know, are they still operating? Are they able to still connect to them? So yeah, we want to know if new resources can still be created, and we also want to know across all sites. So with our distributed architecture, we really want to, with our testing, we want to be able to see, do we have an issue at all sites or do we have an issue at one site? And that greatly helps us identify where we need to look when we do have issues. So with our control plane services, some of the testing we do here is that we test the ports and the processes. So like I said earlier, we test the load balancer endpoint. Can we make a connection? Can the load balancer connect to the underlying members of the pool? Is that all operating correctly? And even, does the API actually have the process running? You know, has it died? We need to know all these things. One thing that we found was that OpenStack, until recently, didn't really have a good way of testing these services from a load balancer point of view. We've seen now that in Pike, they've started including a middleware plugin for health testing, which is quite useful because it's a very simple test and it's useful to be run from a load balancer at a high frequency as a way of just having a basic sanity test that the service is up. There's a few of the projects now have adopted this and enabled it by default in the policy.json for the Pike release, but many still haven't. So we are shipping a modified policy.json for those services that don't. We're now calling that from the load balancer to test that the members of the pool are operating correctly, and we're also testing it now from Nagios as well, so that we can get alerts sent to us when one of those members goes down. We're also using Nagios for some basic functional testing as well. For example, I've got two examples there. To request a token from Keystone, you know, it's a very fundamental test. If Keystone's not working, then you're not going to get far at all. We've also got a test for Glance where we hit the API and just do a basic test to make sure that an image that we expect to be there is returned. So nice and simple, but is a good exercise of the service. So we also test at a host level. So we want to make sure, obviously, that the box is available. So we test for ping and SSH, and you know those services that we expect to be running are running. NTP, because clock sync is quite critical. File system is a great one because logs can fill up your disk very easily. So you know we have alerts sent to us when the file system reaches 80% full, and that sort of thing. We have an uptime test as well, so that if a box does reboot itself unexpectedly, we'll know about it. And we're a big Puppet shop, so we also have a test for Puppet to ensure that Puppet's run frequently and that Puppet hasn't returned any errors in its run. We also use Ganglia. Ganglia it's useful for diagnosing issues. We can see CPU, memory, network, disk I/O, graphs, and we just use that for getting an idea. If a service isn't operating correctly, we can jump onto Ganglia, have a look, and see if there's any anomalies over the last hour or day, or we can identify sort of trends if network usage has spiked, or things like that. So It's very useful for just having a quick visualization and being able to just pick up any anomalies there. So there's also dependency services. So we run a Ganglia cluster for MariaDB. We've got a couple of tests. One just tests that the service is okay. Can we connect to the database? Can we do a basic query? We also test for the cluster sync status as well. That's very helpful because sometimes it can go down. And when you're running a Ganglia cluster, it just keeps on running. So if you don't get an alert, things could get out of hand very quickly. So RabbitMQ as well, we have a couple of tests. One just tests that the service is up and operating correctly. And we also have another test. It's a custom test that we've written, which connects to Rabbit. It'll check the length of the queues as well. We found that particularly for running cells v1, if there's an issue there, maybe a network issue between one of the sites, quite often we can have a Rabbit queue grow in length quite quickly. This guy knows what I'm talking about. So we've got a test there that can give us an idea if something's going wrong. It's a really good preliminary test, I guess, really simple one that we can get an idea about something going wrong before it becomes catastrophic. So I'm going to pass over to Jake here. He's going to talk about some of the stuff we do around monitoring the sites.
Thank you, Andy. Yep. So Andy has covered how we monitor the top layer services. Now I'm going to go down a bit more and talk about how we monitor the different sites. We have 8 sites around Australia just now, as you see on the graph. First of all, I would like to talk about monitoring instance. We monitor instance to make sure that existing instances that are already launched, they continue working without interruption. We also monitor the sites to make sure that new instances can launch without any trouble. Last of all, I'd like to talk about some testing. These are operator-initiated tests, which an operator can use to quickly troubleshoot a particular site or even a particular compute host, etc. So this is an example of, this is a very simple diagram. So core services is on the right. We have 8 sites around Australia. One of the sites is University of Melbourne. So what we want to do is, existing instance, for example, on the top left, they're already running on the compute host, they are okay. We also want to make sure that new instances can launch. If new instances can launch, this means that the communication pathway between core services and the site is working. That's why we do that test. So how do we monitor instances in each site? So we have a canary instance in each site. This does a few simple tests. A ping test, everybody should be familiar with it. We'll ping the instance to make sure that it's still responding. This would validate that the network connection between the instance and the rest of the world is working. We also monitor simple service at each site. For example, the DHCP service and the metadata service. DHCP service, the instances will need to correlate every now and then to renew their list, so they have to be working. And metadata will be used when an instance boot up for cloud init to get the SSH key, to get a host name, etc. So these are 2 very simple services that we monitor basically by just running scripts like curling the metadata URL to make sure they're still responding, and DHCP, basically a DHCP request. I would like to talk a bit about Tempest. So if you are not familiar with Tempest, Tempest is a testing framework that's developed by OpenStack. So OpenStack uses Tempest to test OpenStack. There are 2 types of tests in Tempest. Basically, there's an API test, which you can use it to test API calls, basically things like Nova create, Nova delete, Cinder create, Cinder delete, This is the full functional test. Basically, you need a working OpenStack installation, and you will sort of simulate a client and connect to it and do everything. The more complex one would be the scenario test. The scenario test tests multiple services together. So an example of a scenario test would be testing a floating IP attachment. So to test whether floating IPs can attach to an instance, you will need to boot up a Nova instance, Nova create, and then you need to create a floating IP from that's Neutron, and then you need to attach that floating IP to the instance, and after that you need to, say, ping the floating IP or SSH into the floating IP to make sure that end-to-end is okay. So we have two tests. Basically, automated tests would be jobs that are launched by Jenkins. This has a custom wrapper script around it. At the back end, we run Tempest, but generating Tempest config is a bit of a hassle, and we have different sites with like a lot of compute hosts. So we have a custom wrapper script that will take a YAML config, and it will generate a Tempest config. This Tempest config is valid for one run, so you can generate a Tempest config for, say, a run against the production cloud, against a particular site, and against a particular host. And then Jenkins would go and kick off this run and get the output. So the output is a text. We parsed it for the result on whether it's a success or a failure. And we will push this result to Nagios via NRDP. The manual test is about the same, but these are jobs that are initiated by a site operator. So these tests are more complex because they test more things. They can be used to test a compute host. So all the operations that the compute host would use, for example, booting up a Nova instance, creating a Cinder volume, and then attaching the Cinder volume to the Nova instance. And because your compute host must have the credentials to connect to your Cinder backend and things like that. You can also use it to test your Cinder controller. We have tests for Neutron controller, and we also have scenario tests. These manual tests are useful during troubleshooting, upgrades, and provisioning. One of the big use is that we have a compute host test. So when an operator in a site, they are bringing up new machines, they have provisioned it, but they would like to know whether the compute host is working before releasing out to production. They can run a test. So this would run through all the things that I've said just now, all the different tests, and basically give a pass-fail. So if it's passed, then the operator can just do a Nova aggregate update and add the compute node into the aggregate. We used to have a checklist that we do by hand whenever we bring out new machines, but yeah, we have all been replaced by Jenkins wrapper now. So an instance boot test, this is the automated test. This does a few things in a very quick succession. Create a key pair, create a security group, create an instance, and when it will pull the instance for the status from wait for it to become active, and when it's active, it will try to ping it, and then it will try to SSH to it. Once it can SSH into it, it can, basically it's a success, and it can destroy or clean up all the resources that have been created for the particular test. The test jobs are launched every 30 minutes in each site. So we do this all the time to make sure that the cloud is healthy. So the automated test was the one. Incident boot test was, I covered the detail just now. We have a tiny Ceros image just to make sure that they boot out really fast. We also have an instance boot test for each flavor. This is just basically to test if the cloud have enough capacity for larger flavors. So the cloud might be able to launch like four small instances, but it doesn't mean that it can launch one bigger instance that has the same amount of resource because of the packing problem, right? So we really need to figure out that whether larger instance can launch. And so we do launch different flavor size all the time. And this also allows us to check not just for capacity, but also if the scheduler is having any problem, because the scheduler decides where the big instance would go. And if you have a misconfigured filters or whatever, the scheduler will put it in the wrong place and it will show up that it's not working. This is the manual test that I've been talking about. So just to run through very quickly, boot instance, SSH, it can get a VNC console. Yeah, testing for that, it's a bit hassle. Snapshot creation, and then the volume attached, and then destroy cleanup, all automated. This is a Cinder test. Cinder test creates a volume, boot an instance attached to it. It also does things like extending volumes and stuff. Basically, this is just to test your Cinder controller. And the next test is a Neutron test. Neutron, we do a few tests like create, delete, all these things like port, subnet, router, floating IP. And just now I've covered it. Put an instance, attach a floating IP, ping to it, SSH to it, make sure that end-to-end the network connectivity is good to the instance. This is an example of our UI that the operator can go into initiate the operator-initiated test. So on in the rate box, there is 3 fields. The first one is the cloud. So the operator can choose a cloud that he wants to test against. Then he will choose an availability zone. We have 8 sites. And then he can also choose a host. So choosing a host is normally done when you have a new host. Or if you just want to test your site, you leave it blank and we'll be testing the site. And this is a Tempest output. So look at the rate box. The error shows up pretty clearly that SSH connection to the particular IP has timed out. So you know that maybe networking wasn't configured properly, or like the instance really didn't come up fully, and things like that. Okay, so with all the automated tests that we run, we generate a status dashboard showing the uptime and the availability of the cloud. On the left will be the different APIs, the different services. So each of the service has an uptime like what do we have here? Accounts, keystone, volume, dashboard, etc. On the right will be each availability zone, each site on their uptime. So we have like Auckland, Intersect, Melbourne, NCI. And we keep this on the status dashboard for everyone to take a look. All right, now back to Andy to talk about the tools that we use.
Thanks, Jake. So to bring all this together, there's a few different tools that we use that I'd like to talk about. So yeah, first of all, alerting. So as we've mentioned throughout the talk, we use Nagios for our monitoring. Nagios is it's not great, but it's kind of the best we have, I think, at the moment. We'll be looking at other tools, but the thing that I find really painful about Nagios is the configuration, and we're able to work around that by using Puppet. Puppet provides us with good Nagios integration, so we're able to attach Nagios tests to services based on the Puppet classes that we assign to it. So we kind of almost get it for free if we bring up new hosts. All of that all of that testing configuration is generated automatically for us. So although Nagios can be painful, it also works quite well for us. We have Nagios configured to send us alerts by email and recently by Slack. The Slack one's interesting because we're able to, especially with the kind of site tests that we have, tests that are specific to the sites, we're able to deliver alerts through Slack to a channel that's specific to that team. So that team is then able to subscribe to those alerts by just joining the channel. So that leaves, there's less configuration work for us to do because we can just send it straight to the channel. And then, if a guy goes on holidays or whatever, he can just leave the channel and it's nice and easy. And that's worked quite well. So yeah, as I spoke before about Puppet, we can add Nagios host and Nagios service resources to our Puppet manifests, so that it's quite simple. Once we do that, we can scale up our infrastructure and the tests just kind of come along with it once we bring up the new host and provision it with Puppet. For anyone else who's doing this, I don't know if they get to a certain size, the Puppet generating that config for Nagios can get really slow and be really fragile. So we're using a tool called external Nagiator, and what that does is that actually connects directly to PuppetDB, and it queries PuppetDB for the Nagios resources, for the Nagios host and service definitions attached to those hosts, and it generates the Nagios config for us using that, and that is far more reliable and much faster. So I think when you get up to like maybe 200 hosts or something, having Puppet do that directly for you just becomes a real nightmare. So we deploy Ganglia to our hosts when they're provisioned with Puppet. We also configure central syslog shipping, which is a must for anyone who's operating a large amount of infrastructure. I'll talk a little bit more about our central logging in a minute. The dashboards that Jake was showing before, we actually pull this information from Nagios. As many know who use Nagios, it doesn't really have good APIs, so we actually have some nasty code which actually scrapes that information from Nagios. It's nasty, but it works and it's been quite reliable. So this is an example of what we see from our Jenkins server. We're using Jenkins job builder to generate all these for us. So we've got some almost simple YAML where we can kind of template these job configs. We have, you can see in there, we've got the Nagios flavor tests, large, medium, small. There's more tests that run off the bottom of the page there for each of the sites. We also include some cleanup tests as well. Tempest, if something happens with Tempest, sometimes it won't clean up the resources. So we have a manual job there that runs the OpenStack project OS Purge, and OS Purge can go through and clean up those tenants for us, which helps reduce some faults. You can see in that example there, we had an issue there with extra large instances. We had an issue where one site became the default by the scheduler, but that site didn't have the disk capacity to accept flavors of the extra large size. I think we had something like 200 gig disk associated with that flavor, and it was too much. And so those jobs were being scheduled, because Cells v1 isn't that smart, the jobs were being scheduled to that availability zone, and then once they got to that zone, they were failing because the disk wasn't available. So this was a really good test because we were able to identify that was the issue, and the fix here was that we introduced a disk filter plugin to Nova to sort that out. And then those extra large instances went to a different site and everything was happy. That's the Nagios status page there of our automated tests. You can see there the extra large is red. We got the really helpful error there that no valid host was found. Usually the error is much more helpful, and the operators of the sites can actually, they have some idea of what to do. But in this case, the error was a bit more complex. So I spoke a little bit about for the central logging. So we're running an elk stack, so Elasticsearch, Logstash, and Kibana. So we have VPN links that go out to all of our hosts from the VPN from all our hosts to the central logging server, and the logs get delivered over that. Logstash combines all the logs together, puts them into Elasticsearch, and then we can visualize them with Kibana. Gives us pretty dashboards, and it's really helpful for diagnosing issues. I've got a graph here. So this is showing, we've showing a whole range of things here actually. We've got, from the top left there, total requests coming in. It's probably a little bit hard to see there in the back, but you've got that purple bar there is the Nova requests. So Nova's most popular, and then we've got the red is Keystone. So you see we've got total requests, max response time, average response time, and some response times. See the middle bar in the middle there, that's all traffic stacked, and we've got the average response times at the bottom. So in this slide, you can see here, this is a really good example of something that where these graphs really helped us was when we had an issue with a rogue client making a lot of requests to Keystone. Our Keystone wasn't quite able to handle that properly. And so you can see from the top graph there, the blue dots are the Keystone requests, and the average response times were just way too high. I think that's about 20 seconds or something. So it was, when you get reports from your users that cloud is slow, I mean, it's a really unhelpful comment, but by having these graphs, we're able to look at them quickly, and in this case, we're able to see, yes, it was actually slow, and it was because of Keystone. And so in the end, we didn't actually need to fix this. The client stopped making requests. So it just dropped away back to normal there. But using this dashboard, we're actually able to see the IP address of the client, and we're able to identify who that client was and what they're doing, and we ask them politely to fix their code. So some further work for us is that we'd like to store our Tempest test results in Gnocchi, so that we have better historical records for pass and fail. At the moment, they're just stored in the Jenkins logs, and they get rotated after a week or so. We'd like to also have alerts based on thresholds. So in the example before where the Keystone response time was going up to 20 seconds, ideally we would have had an alert well before then at say 5 seconds even, so that we get a heads up before users start complaining. And then to extend on that, we'd really like to have alerts, smarter alerts based on trends, so that we could see that if a service has been operating at or had a response time of 5 seconds. You know, if it did go up to 10, if it did have a sudden spike, we were alerted based on that rather than having to define manual thresholds. But that's a wish list thing, really. So I think that's it from us. I'd like to turn over to you for any questions you might have.
So what are the monitoring tools that you consider besides Nagios so far?
Well, we've heard a lot about Prometheus, which is something that we'd really like to have a look at. Anything else, Jake, you think of? Yeah.
Just Prometheus, yeah.
Yeah.
Basically, what we want to do is alert on trends. So that's where we are going. So any tool that does that would be good.
We've been fairly stable, really, considering the amount of infrastructure that we run. So Nagios has been, it's sort of better the devil you know for us. So we've kind of just dealt with its shortcomings, and it's probably been okay. But I would like to use something else.
Go back to that keystone being thrashed. Have you looked at anything like rate limiting per host or per user?
Yeah, we have actually. Yeah. That's it's on our never-ending Trello board list of things to do. We think it would be fairly straightforward for us to implement this on our F5 load balancer. We've got a team actually who manage that, and they've sent us some information that looks quite promising there. So we think rate limiting by IP address, or even maybe Keystone, maybe not so much with Keystone, but it would be great if we could rate limit based on the specific tenant as well. If we do the SSL decryption on the load balancer, so we think we'll have enough context to be able to extract the tenant ID to be able to rate limit based on that if we can. But I think the first step for us would be, at least with Keystone, is to rate limit based on the IP address. Yeah.
Another question is, why do you run this following over VPN?
Because we've got sites all over the place,
Yeah.
and there's firewall rules, and there's some stuff that's out of our control, basically.
We don't want it to traverse the internet in clear text, basically. So
Yeah. I think we're using RELP for the logging, and I'm not sure if that's encrypted or not.
I'm not sure.
I have a feeling it may not be. So it gives us encryption as well.
Have you considered Monasta for the framework, which supports Nagios?
We haven't really. I was sort of under the impression that it might have been a bit heavy for us, but it's certainly something that we should be looking into anyway.
Do you have any requirements for tenant monitoring, or is it just monitoring of the infrastructure itself? But do you have any monitoring of tenancies?
Repeat for the back. Repeat the question.
I'll repeat the question. Yeah. Is there a requirement for monitoring for projects?
Yeah.
We haven't had. I don't think we've had that specific requirement yet. I think there might be some groups some of our users who would be interested in something like that, but at this stage it's not been a priority for us.
Yeah, I just wondered if any of your Jenkins job specs are either open source or open source. So we're kind of in a situation where we're quantifying value manual testing down, but if we could skip ahead and use some real work, good.
Yeah, that'd be great. Actually, there's a lot of stuff that we talked about in here that's not public, and it should be. So I would recommend that you shoot us an email maybe, and I'd be happy to provide you with some redacted versions of the stuff that we have. Some of our repositories have credentials and stuff in them. We would like to have a better solution for that as well, so that we can put all of our job information just up on GitHub and make it publicly available. But there's a few things that we think might be interesting to a wider audience, which might be the Tempest config generation, because it's a bit of a nightmare. You know, some of the stuff around Nagios, and yeah, we use Jenkins for a lot of stuff. All our builds run through Jenkins in the same way that kind of OpenStack have their gate. We do a lot of testing around that, testing for the monitoring jobs. We use it for building packages and building images and stuff. So there's a lot of interesting stuff in there that could be useful. So yeah, if you shoot me an email, I'm happy to share all the stuff we've got with you.
Do you trigger any sort of evacuations or migrations or anything with these areas, or do you leave it up to the manual integration?
No, it's manual at this stage. We tend to leave that to the teams who operate the sites. Because of the way we're funded and we have this real separation between us who operate the core level services and the guys who operate the teams. So we don't actually have infrastructure. We don't have access to a lot of the infrastructure that they run. So we leave it up to them.
Would they get a feed of your...
Yeah, they get all the alerts and they have access to all these systems, so they can check themselves. Yeah.
Yeah, and some of the tests, they are initiated by them, so we don't want to kick off any automated task, just in case it's an expected result and things like that. Yeah.
Yeah. I think we might be out of time, are we?
Yeah, we are.
Yeah.
All right.
All right. Thanks very much.
Thank you, guys.